Example C, we're going to solve for x. So we're looking for the exponent on 10 that gives us 10,000. Now we could put this into our calculator, but we really should know that 10 to the power 4 is going to give us 10,000. So that's going to make the x value, the value of x equals 4. Okay, and our calculator will verify this. For this one here, we're going to rewrite this as a log. So log base 10. The argument is going to be 18,000. Log always equals exponent, so it's going to be equal to x. This one here, 18,000 and base 10 are not related, so we're going to need our calculator. So when we plug this into our calculator, we get about 4.255. Okay. For example 4, we're putting these into exponential expressions. So my base, again, my base, my argument, my exponent. I'm going to have base 10, exponent 5 equals the argument a. So a is equal to 10,000. We can actually solve for this if we want. We'll do the same thing here. We have our exponent a, base 10, argument 100. So when I write this equation in exponential form, I get 10 to the power a equals the argument 100. So the reverse is true here. We have our base, we have our exponent, we have our argument. As long as we identify those three distinct parts, we can rewrite this as a log. So we end up with log, the base is 10, our argument is x, and this is going to be equal to the exponent, which is 5. Okay, so there's our converting to our log form. Now, in this case here, the log form, exponential form lets me solve for x. The log form doesn't. So looking at this next one, log, our base. Okay, we need to identify our base. We need to identify our argument, and we need to identify the exponent. So when we write this, I get log base 10. Argument is 120, and that's going to be equal to our exponent x. Okay, in this case here, if we want to solve for x, we can use the log. So if I use my log base 10 of 120, that gives me 2.079. So x is 2.079.